Good morning, students. This is the lecture for CSC 2 for the subject Engineering Mathematics 2. Students, as we have finished our syllabus, these lectures they are only just for your revision purpose of some important topics. Okay, so as we have started the revision of the tests, we have done the revision of Z test, which is also known as large sample test, then T test also. Then this is the lecture regarding the F test, which is also known as the variance ratio test. So I'll tell you that how F test works, how it applies in practical life. These things we are going to discuss in today's lecture. So as students, F test, as we know, the samples they have been categorized into the two parts. One is small sample and other is the large sample. So the small samples are basically those samples whose size is less than 30, and the large sample they are considered as those samples having more than 30 observations. Okay, so as we have discussed the Z test, which is the large sample test in which the sample size is greater than 30, and in T test it is dealing with the small sample, that is the sample having size less than 30. So the next test is F test, which is also known as, the alternative name is the variance ratio test. It is a test which is applicable for the sample whose size is less than 30. So what is the difference between now T test and F test? The similarity is that both tests are applicable to those samples whose size is less than 30. Okay, but what is its application? How we can distinguish that which test we have to apply? It will depend upon its application. Students, if we want to check the significance difference of single mean or population means, or we can say whether I would like to check whether this particular sample has been drawn from that population possessing that particular mean, or the difference between the means of two samples or two population or sample and population is significant or not. In that case we use the T test. Basically when we are dealing with the application of difference of means, then we use the T test. But in the case if we use the difference between the population variances, or whether we would like to check whether this particular sample has been drawn from that population which is possessing that particular variance, then we use the F test. Okay, so the similarity between these both tests is that they are applicable for the small samples, that is the sample having less than size 30. But the dissimilarity, that how we can come to know which test we would like to applicable. If we want to deal with the difference of means, then we use T test. But if I want to check the difference of the variances of two samples or two populations, then we use the F test, which is also known as the variance ratio test. So students, let us start with the numerical. First of all, again the same steps are there for testing. That is, the very much first is we have to set up the null hypothesis. Then the second is we have to set up the alternative hypothesis, that is the statement which is alternative or which is complementary opposite to the null hypothesis. Okay, then we use the F statistic. The F statistic is given by S1 square over S2 square if S1 square is greater than S2 square, and it is equal to S2 square or S over S1 square if your S2 square is greater than S1 square. That is, the value having more value, having greater value, it will be placed in the numerator, and the term which is having the less value as compared to the other value, it will be placed in the denominator. So if your S1 square is greater than S2 square, then I will write S1 square in numerator and S2 square in the denominator. But if your S2 square is greater than S1 square, then you will place this S2 square in numerator and S1 square in the denominator. Okay. Now the question is, what is S1 square and S2 square? I have illustrated, or I have written the formulas for S1 square and S2 square. These things you have to keep in your mind before starting the numericals or applications of F test. Okay. So S1 square is given by 1 upon n minus 1 sigma xi minus x bar. S2 square is sigma 1 upon m minus 1 sigma yi minus y bar whole square. Okay. The next numerical that I am going to discuss, this type of numerical is very much important from the examination point of view. This type of numerical can come in exam for long answer type. Basically, this numerical is containing the application of both the T test and the F test. Okay, students, let us read the statement firstly. The two random samples, they give the following results. We are having the two samples, sample 1 and sample 2. In In second column, the size is mentioned. The size of sample 1 is 10 and the size of sample 2 is 12. So both the samples, they are having size less than 30. So we are dealing with the small sample test. We will either apply t-test, f-test or chi-square test. So z-test is exempted over here because the sample size is less than 30. Okay. Then we are having the sample means. The sample mean for first sample is 15 and for the other sample is 14. Then sum of squares of deviation from the means is 90 and 100. We just want to check whether these samples, they came from the same normal population at 5% level of significance. We just want to check whether these samples, they have been drawn from that population which is possessing the normal distribution. We just want to test this. Okay. So if I want to check whether this normal population is possessing the normal distribution or it is following the normal distribution. So we know that the normal distribution is having the two parameters, mean, mu and variance sigma square. So if I want to check whether these samples, they have been drawn from the population which is possessing the normal distribution, we will check the two things. Firstly, the equality of means and the equality of variances. So equality of means, as I told you, we will check it by using the t-test, and equality of variances we will check it by the equality of variance we will check by the variance ratio test. Now the question here arises, which test will be applicable firstly? Students, we will firstly apply the f-test. That is, we will firstly test the equality of variances. The reason behind is that secondarily, I will check the equality of means firstly by using p-test. But the basic assumption of p-test is that the test on which we are applying the t-test is that they should have the equal variances, and that can be only judged by the f-test. If they doesn't possess the equal variances, then we cannot apply the t-test. Okay, so we will firstly check whether these two samples, they are possessing the same variances or not. If yes, then only we can apply t-test. But if it is not having equal variances or there is no significant difference between the variance of the two samples, then we will not apply the t-test. Okay, so firstly we will apply the f-test for checking of the equality of variance. Okay, so first of all, I have also written to test whether the two samples, they have been drawn from the same population. We will firstly check the equality of variances by using f-test, and then the equality of means by using the t-test. So equality of variance, first of all, again the same steps of testing we will follow. I will firstly set up the null hypothesis that sigma 1 square is equal to sigma 2 square. The alternative hypothesis will be the statement which is complementary to the null hypothesis that sigma 1 square is not equal to sigma 2 square. Now what we are having, n1 is equal to 10, n2 is 12, x1 bar is 15, x2 bar is 14, sigma x1 minus x1 bar whole square is 90, and sigma x2 minus x2 bar whole square is 108. These all things we are already given in the question. So here I am going to evaluate capital S1 square and capital S2 square. So S1 square is given by 1 upon n1 minus 1 sigma xi minus x1 minus x1 bar whole square, which is coming to be 10. Please verify it, students. And S2 square is 1 upon n2 minus 1 sigma x2 minus x2 bar whole square, which is coming to be on calculation 9.8. Please, students, verify it. Now the value of S1 square is greater than S2 square. So what will be the formula for F statistic? It will be S1 square over S2 square. Okay. So writing down the value of S1 square and S2 square as 10 and 9.82 respectively, I am getting the answer as 1.02. Please verify it, students. So now we will conclude, or we will calculate the table value. Again, students, if the level of significance is given in the question, then you have to follow that. But if it is not given, it's twice as yours. You can take 1% or you can take 5% also. So at 5% level of significance, the degree of freedom, that is n1 minus 1 comma n2 minus 1. So 10 minus 1 9, 12 minus 1 is 11. The table value, you can, students, verify it from the table. It is 2.896. Now it's time to make the comparison between the calculated value and the table value. Now the absolute calculated value is less than the table value, so your null hypothesis is accepted. Means the variances are equal, that is, there is no significant difference between the variances of the two populations. It means the variances are equal. Now we can apply the t-test, because if their variances, they don't come to be equal, then we cannot apply the t-test, and hence we will conclude the question that the two samples, they have not been drawn from that population which is possessing the normal distribution. Okay. just check the equality of means now. Again the same steps we will follow. First of all, I will set up the null hypothesis h naught, which is given by mu1 is equal to mu2. That is, there is no significance difference between the means of the two samples. And the alternative hypothesis, the statement which is complementary to the null hypothesis, that mu1 is not equal to mu2. Now capital S square will be calculated like this: n1 s1 square plus n2 s2 square over n1 plus n2 minus 2. I know the value of n1 and n2 as 10 and 12 given in the question. Now I will evaluate small s1 square and small s2 square. So small s1 square is being evaluated like this: 1 upon n1 sigma x1 minus x1 bar whole square, which is coming to be 9, and s2 square is 1 upon n2 sigma x2 minus x2 bar whole square, which is also coming to be 9. So putting the values of n1, n2 and s1 square, s2 square in capital S square formula, in this formula students, please verify the calculation. The value comes to be 3.146, small capital S. Okay. Now what is the formula for the t statistics? The formula for t statistics is given by x1 bar minus x2 bar over capital S under root 1 upon n1 plus 1 upon n2. So it comes to be x1 bar is 15 minus 14 over, I am writing the values, and on being calculated I am getting the calculation as 0.7. Please students verify this calculation. Okay. Now I will take the table value again. Again students, if the level of significance is given in the question, then you have to follow that. But if it is not given in the question, then its choice is yours. You can take 1% or 5% also. So at 5% level of significance, with degree of freedom is n1 plus n2 minus 2. That is 10 plus 12 minus 2, which is 20. The table value is coming to be 2.086. Okay. Now I will make the comparison of the absolute calculated value with the table value. So students, keep remember that we have to compare the values of absolute calculated value, because if your calculated value is turning up with the negative sign, you have to take it positive sign. Okay, you have to ignore the minus sign. So that's why I always stress on the word absolute calculated value. That is, you have to take the mod of that calculated value. So if your absolute calculated value is less than the table value, then your null hypothesis is accepted. Means there is the equality between the means also. Okay, so it means there is no significant difference between the means of the two samples. Okay, so there is the equality between the means, also there is equality between the variances, and we know that the normal distribution is having two parameters, mean mu and variance sigma square. So both are getting equal. So we can say, or we can conclude in the last, that the two samples which you have given, they have been drawn from that population having the same variances, and have been drawn from that population which is possessing the normal distribution. Okay, so students, this application and this numerical is very much important from examination point of view. In what sense? Because this numerical can come in long answer type question, because it contains the applications of both t-test and f-test. So students, if I just want to check whether the given two samples, they have been drawn from that population which is possessing the normal distribution, then we will firstly apply the equality of variances by using the variance ratio test, which is also known as f-test, and then the equality of means by using the t-test. There is compulsion that we always have to apply firstly f-test, then t-test. The reason behind it, that because t-test is applicable only if there is the equality between the variances of two samples or two populations. Okay, so if they are not equal, then we cannot apply. Okay, so this is compulsion that we have to firstly apply the f-test by using the variance ratio test. So what we are doing, so as if one of the test fails, that is if in one of these two hypothesis, one hypothesis is failed, then we cannot conclude that the samples, they have been drawn from that population which is possessing the normal distributions. So both equality between both the variances and means, they should be equal to conclude that these two samples, they have been drawn from that population which is following the normal distribution. Okay, so this examination, this point or this concept, numerical, is very much important from examination point of view. So go through this numerical with pen and paper. Okay, listen this video very carefully, and if you find any kind of doubt, is there any query, please contact me through WhatsApp, through call me, or you can mail me also. Okay, hope so the content of this video lecture of that is the revision lecture basically is clear to you. If you have any doubt, please don't hesitate and ask. Thank you.